geometric mean is the middle number of a geometric progression. So anything that fits in between any two numbers in a geometric progression, we consider to be a geometric mean. Now this is similar to arithmetic mean in that arithmetic mean is the middle number of an arithmetic progression. So if we have A and B, the middle number here is X. The arithmetic mean is just the average. So we add the two numbers and divide by 2, we get an average. If we add the outside numbers here and divide by 2, we get the middle number of a arithmetic progression or plus progression. Here is similar, but we're looking for the middle of a times progression. So this is we have to use a little bit different math, but the idea is similar. So if I were to solve this, I could do it a couple ways. I can just put this into my formula and I can just say 4 times r equals x, and I can just say x times r, that must be equal to 36. And I can use some sort of system of equations here. I'm going to replace, I want to solve for x, but I'm going to solve for r first. So solving for r, I'm going to replace x with 4r. R equals 36, r squared equals 9, and I get r is equal to plus minus 3. Okay, so that then makes the x value 12 or negative 12. So I times by 3 to get. That's going to be my progression from 4 to x to 36. And that's perfectly fine. We can do this way, and we can use our formulas to do this. But we can also do this in a slightly different way. And it's different in that we could use the same idea. The arithmetic mean is the middle of an arithmetic progression. We find it by adding and dividing. The geometric mean is the middle of a multiplying progression, so we're going to find this by multiplying and rooting. Okay, so I'll show you how this works. So we have our outside numbers. We can multiply them together, and this ends up equaling x squared because we need to undo this multiplication. We need to find the middle of multiplying of two numbers. Well, to find the middle, we need to undo that multiplication, and we're going to end up using roots. Now, it might not be very clear exactly how it works, but the idea should make sense. We're finding a mean. In this case here, we did it by addition. Here we're going to do it by multiplication. Here we divided to get the mean. Here we're going to root to get the mean. So x then is equal to plus minus, if I multiply these together, I'm going to end up with 144 square root. So I end up with plus minus 12, and that's what I got here. If my common ratio was 3, I would end up with plus or minus 12. So x is a geometric mean, okay? And I can find it by multiplying the outsides and rooting to find the middle. Just like I added the outsides and I divided to get the middle. So it's a similar idea. Okay? Now, if you don't remember that property, you can always go back to just solving it, plugging into the formulas and using maybe some system of equations, and we can work it out that way. But a geometric mean, if you understand what a geometric mean is, it's the middle of a multiplying progression. Okay, so if I want to find 3 geometric means, so that means I have 3 numbers in between 4 and 36. Well, I can use this same property, and I know that this must be halfway between 4 and 36. Okay, so that's got to be halfway between 4 and 36. Now, I can still use that halfway principle here, and I can find the halfway point, this number here, which I'll call A, and I can find the halfway point by saying that a squared is equal to 4 times 12 is 48. Okay, I know that this, if this is negative, this is going to be positive. If this is positive, this is still positive. Okay, so this is then, actually we can't, when we look at this, we can only get a positive here. So that would just have to be the positive 12. So we end up with a squared equals 48, and then square rooting. The square root of 48 is then going to end up being the middle between here, and this will be plus minus. Okay, so if I multiply and if I simplify this, this is going to be 4 root 3. Okay, so this is plus minus. You can see that if I multiply by root 3 and then multiply by root 3 again, I'm going to get to that point. And then I know that this answer must be 12 plus minus root 3, but I could also find that same value. Instead of using the common ratio to jump, I can use the same process again. B squared is equal to 12 times 36. So 12 times 36. And that works out to be 432. So B is equal to plus minus the square root of 432. Well, 432, this is same as 144 times 3, and it simplifies to plus minus 12 root 3. So it's the same thing. So we can again find the middle using a ratio, but we could also find the middle by using this idea of a geometric average. So geometric means is similar to arithmetic means, but arithmetic means are linear progression, geometric means are geometric progressions. And if I look at how it progresses, so this red line represents arithmetic sequence because it's a straight line, it's a linear equation, and it goes up by plus d plus d. A geometric progression is exponential, and it's a curved line. So we can see that finding the middle of a geometric progression is slightly different than finding the middle of an arithmetic progression. This is to do with adding the outsides and dividing by 2 to find the middle. To find that blue line, and it's curved because it's not a linear progression. It is to do with powers. I can multiply the outsides and root, not divide but root, to get the middle. And that's the difference between arithmetic progression and geometric progression. Also the difference between linear progression or linear functions versus an exponential function.